Good afternoon and a very warm welcome to all the participants and our speakers. This is Bakhtavar Mahmood and I'm going to moderate today's session, which is Innovation in Micro Gas Turbine and Cutting Edge Propulsion Technologies in Pakistan. This is a joint venture of Pakistan Aerospace Council and Asian Air Institute of Industrial Lab. Pakistan Aerospace Council, it is a cluster organization for the enterprise activities in the aerospace, defense, and high-tech electronic market. It was formed for global promotion of high value addition and high technology manufacturers of Pakistan, while meeting the national trends for technology acquisition as well as export-led sustainable growth of Pakistan aerospace industries. PAC, Pakistan Aerospace Council activities, they're focused around the following key objectives that includes improving the image and profile of Pakistan's high-tech sector, influencing policy debates and procedures of most importance to the industries, supporting Pakistan's high-value manufacturing and supply chains, encouraging investments in technology and innovation, supporting business development and opportunities in the global market, increasing members' value, and sustainable growth of private high sector in Pakistan, high-tech sector in Pakistan. Ladies and gentlemen, this webinar is going to be conducted with the formal proceedings of introduction of our guest speakers. We'll have a brief introduction and then we'll move on to the question and answer session with our panelists and our speaker for today. If you have any sort of questions, you will be asked to please raise them at the end of the webinar, or you can also send your questions in our chat and our panelists will try to accept your questions. I hope that most of them are answered as well. So I would like to introduce our speaker for today. Our speaker is from SoluNox, and it is an R&D company and having core expertise in the mechanical engineering, avionics, aerospace, naval architect, mechatronics, and armament and explosives. We are the OEM for following product ranges that includes the high-speed launching system, conventional and unconventional airframes, micro gas turbines, IR flares for target practice, IR ignition system, parachute recovery system, mini submarine, and unmanned ground vehicles. Our speaker for today's session is Engineer Captain Retired Sajid Ali Khan Tareen, PNG, BNG, Marina, UK, member ASME, member ASTM, member IEP, and also is a retired Pakistan Navy captain who has served on board submarines for over 30 years. He's also a graduate in the mechanical engineering and MSc in maritime studies. He has qualification in the contract management, project management, and strategic management. He possesses a vast experience with the submarine design and construction, and he has established SoluNox Pvt Limited. That is an emerging R&D setup in the aerospace and high-tech industry. SoluNox, it produces micro gas turbines for the propulsions and electrical power. Aerial applicator of pesticide on the crops is another area of expertise, and it is a business model for cheap application has been developed for the third world countries, and he's a leading R&D in the teams of SoluNox. So we have with us our very own the CEO of PAC and AIA, our panelist for today's session, Dr. Arshad Ali. Dr. Arshad is a recipient of Sitara Imtiaz and Pride of Performance from the Government of Pakistan. He has completed his PhD from United States of America and has served as the Executive Director, Higher Education Commission, HEC, Vice Chancellor, National Textile University, Faisalabad, Dean, NAST, Islamabad, and Pakistan Air Force. So, Sajid Saab, first of all, welcome, and I hope that we have a great session today. I would request you to please unmute your mic so that we start with the question and answer session.
Thank you very much for your...
You are and have pursued naval career, but how did you get the idea of the startup in this cutting edge technologies and that too in the aerospace? Would you like to share with participants of this webinar that what is SoluNox and how did you manage to do what your company is doing at the moment?
Right. Dear Bakhtavar, in fact, you have got two parts of your question. Maybe I'll answer your first part in the later, but I'll go how to describe you about what SoluNox is. So if you allow me, just if you have some few understanding. Can you see the presentation slides?
Not yet.
Not yet, yes.
Share screen में जाएगा. Okay. Is it okay now?
Yes, it is available now.
Yes, we've started seeing it now.
Just to introduce you what SoluNox is,
Can you please take it to full screen?
sir. It's okay now.
Yeah, thank you.
Let us see.
So basically, SoluNox was established in March 2017 in the private sector for research in cutting-edge technologies. Since inception, SoluNox has been engaged in various research projects and overseas studies. Mainly, our research areas are aerospace and marine unmanned systems, materials, propulsion systems, electrical power generation, and health monitoring support systems. At the moment, SoluNox owns 5 patents, and we are at the moment in the process of getting them registered internationally. SoluNox basically, before it start, now coming to your question, that we started this process of establishing this company. Before that, we were stepping into cutting-edge technologies. So we had to analyze what all major companies in the related field have progressed right from the scratch. To do this, we studied them, those companies, we analyzed them, and we collected a lot of knowledge source of research materials, patents, online libraries, and we had to take membership of professional organizations like I was informed in the start of the presentation, member of American Society of Mechanical Engineers and American Society of Testing Materials and Royal Institute of Naval Architects, UK. And the SoluNox is member of 3 committees for formulation of standards at ASTM. And moreover, we have, just to strengthen our company, we have concluded some R&D collaboration agreement with university, academia, and other companies across the 3 continents. We have contracted technology partnership, mainly strategic one, based on sharing of our research together. And now we are able to, now we are registered as a supplier in some of the renowned aerospace directories also, so that we have direct access to the companies globally. Moreover, we have networked into industry also, so that for manufacturing process, because the type of industry we are working at the moment is needs a lot of precision and very dedicated design processes. So we have done this networking with the companies. Then some of the technical specification in the process we have done that major our products are smart products. We have focused our attention towards the propulsion systems, automation and control systems, and system integration. We have some process specializations because we involve precision manufacturing, as I told. We develop our expertise in aerodynamics, hydrodynamics, signal processing, platform design, integration, modeling, simulation, prototyping, and in the end, but major part is in the safety of all these systems. Now, and next, you'll see that this is the resource, human resource experts we have. With us, we have aerospace experts, combustion experts, avionics experts, mechatronics, automation. In the end, we have those who are the trade experts doing the diplomas. Now, coming to your second part, how I started this this process of aerospace, despite being in the Navy and doing serving in the submarines. In fact,
Yes.
Just for your information, that I started my career as an aeronautical engineer, but somehow turn of the events took me to the Navy, and eventually ended up getting commission in Pakistan Navy, and then joining submarine service. The submarine service itself is a cutting-edge technology. So in a way, I'm working at the moment 2 extreme technologies in aerospace or submarines. Rest in between is a mediocre technologies in that sense. And how your question is how I came into developing these gas turbine and everything, because in fact our study mainly just did not start all of a sudden. We have a team, those who are working for quite some time, but they're working in own capacities in gas turbine technologies or aerospace technologies. But our main effort was to pick them on one platform under SoluNox. But now for specifically for the turbines, there is this last complete process of turbines started, micro gas turbine started just last 6 years ago, 6 years ago. Before that, in the next slide, I'll show you the historical perspective. I'll share with you how it evolved, micro gas turbines. But mainly my focus remained was what is happening globally on this projects. At the moment, you must, for maybe information or maybe have some knowledge about this, United Nations Framework of Climate Change is a framework for this climate change. They have set standards of zero emissions for all such systems. So this was one motivation. And the other one, the European Union effort on this development of the gas turbine by 2050. Entire European Union is targeting to reach this target of zero emission by 2050. And to this end, the European Union has already invested 1.6 million euros for studies and research. And for this process, they involved at least 12 expert companies to develop micro gas turbine for 10 kilowatt electrical, which they have done in 2014 and 16. And in 2018, European Union again tasked 56 companies in entire Europe working on different specialist technologies, starting from the micro gas turbine materials, various bearings, their generator systems, and many other technologies which are required. You'll see in the next slide also that how these technologies are being matured over the period, and how many companies in Europe alone has put in their effort to mature these technologies. And there was last assessment by European Union in which almost, as I said, 36 companies under the leadership of European Turbine Network. They actually conducted a complete assessment of entire European Union to develop these micro gas turbine in future, and how to bring these micro gas turbine into mainstream of renewable energy. Now, in micro gas turbines, please, you can be asked.
Yeah. So, sir, my next question will be more specifically about what micro gas turbines are. Can you please explain it for the interest of the audience who are actually laymen, and for someone who has a bit of knowledge about these systems? And can you also please throw some light on the manufacturing process as well?
Okay. Just for the start, I'm sure all experience from the aerospace are sitting here, and somehow, as you said, maybe some those who are not related to this technology or this engineering background. Basically, gas turbine is a heat engine with a continuous flow. In comparison to reciprocating engines, they use pulsating flows. This type of turbines, these engines have a compressor, a turbine, and a combustion chamber, where this heat can be applied in different modes through maybe fuel injection, and you'll see through new methods are coming for adding heat to the combustion chamber. In this type of engine, generally they are mounted on the same shaft. Micro gas turbines generally are mounted on the same shaft, and that is why they are popular in this part of the world of aerospace. At the moment, there is no standard definition of micro gas turbine. In fact, initially it was considered under 1 megawatt will be considered as a micro gas turbine, but subsequently this definition kept on worked out by many engineering associations and countries. So at the moment, under 400 kilowatt turbine is graded as a micro gas turbine. And this micro gas turbines, you can see in the cycle process cycle. This is a Brayton cycle. It follows a Brayton cycle. In this process, the compressor raises the air pressure, and from process 1 and 2, maybe if it is visible to you, then it is directed to combustion chamber, where heat is added via fuel combustion through heat exchanger or concentrated solar power. Heat is added, and then again in turbine at 3 to 4 process, you can see the turbine expansion in turbine takes place to produce power. And this turbine drives compressor and generator, or the efficiency of these turbines can be added by a recuperator like this on the return cycle to increase the temperature in the combustion chamber so that the economy of fuel can be done. Then some of the historic perspective related to micro gas turbine. As I said during my presentation, that development started in 1980s. It is not a new subject basically, but the drive for this development was automotive industry, because at that time automotive industry was looking for an alternate for reciprocating engines, and mainly because of the fuel flexibility, reliability, and low emissions in the micro gas turbines. However, at that time, maybe is some reason this did not get attraction at that time. But again, in 1990s, use of high-speed generators evolved, and the interest also developed in hybrid vehicles, and it was considered suitable for these hybrid vehicles. And subsequently, the concept was again picked up by decentralized power in 2014, when European Union and after UFCCC declared some standards for low emission in atmosphere. The important part of this micro gas turbines are they have low maintenance and compensate for high capital cost. Currently, interest is rising due to low NOx in this gas turbine, and interest is developing now. Now coming to micro gas turbine design and build. In this slide, you will see the micro gas turbine, the design process. The most critical thing about gas turbine and the process of R&D being expensive in micro gas turbine or turbine technology is this all iterative process. Every process, right from the design board till the final delivery, it undergoes iterative process. That is why this causes some expensive involve of high expenses. So the first design process starts from the Brayton cycle, and in this process, various element of gas turbine design are finalized. Generally, mass flow, the temperature ranges at different stations in the gas turbine, and at the same time, the selection of material is also done. Again, mind you, just for repetition, it is an iterative process, and continuously back and forth movement between the designer, the end user, continuously goes on till the time a suitable compromise is adjusted. And then you'll see the all micro gas turbine has some auxiliary systems. This auxiliary system is again it's a process. It undergoes an iterative process during the design, and then engine control units which control the complete process, because now these gas turbines cannot be controlled manually for sure. So to make them smart and efficient, these engine control units are becoming more smarter now. And then comes the power generation unit, the generators. They are. Can anybody guess what is the RPM of micro gas turbine? It is at times cause jaw-dropping gestures, because these turbines run at RPM from 144,000 to 400,000 RPMs, and temperatures are in the range of 350 to 850 degrees centigrade. So it's a huge process of engine machine which is involved in this complete system. And I was telling about the generators. Now, with the evolution of generation technology, the generators are running with high speed of 400,000 or 140,000 RPMs. This has become very much miniaturized. So entire micro gas turbine becomes a very miniaturized in dimension, or maybe less than a cubic meter. Can develop a huge power, about 50 kilowatt power for a micro gas turbine. In this design process, the most critical of the element is the balancing of the shaft, and the pool assembly. Because the amount of RPM that is involved cannot afford this balancing. So, Alhamdulillah, SoluNox has developed this capability to do all this process. And then another element of this micro gas turbine success and the possibility of having such a high rotation is their bearings. And the evolution in these bearings started from general bearing to now hybrid bearings to air bearings and magnetic bearings. And Alhamdulillah, we have this access to these technologies now. Okay, now let's move to some of the parts which we manufacture in our facility. These are two versions, SLX 120 NP and SLX 180 NP. They are 120 Newton and 180 Newton respectively. And our research is continuing, and we have plans to further improve these systems for relatively higher powers.
Can I have a quick interruption here?
Hello?
Yeah.
Okay.
The parts you just show, it's designed by you and manufactured in Pakistan.
Yep.
Yep. So I was seeing in your last slide, you said the bearing and the generation, it's running about 1,000. So how you actually kind of manage it? Because I didn't see it. You are not using any kind of actuators. You are not using any kind of like a balances devices. So how could you be so sure that these bearings and the generation that running at that high RPM will not like destroy each other?
You'll see our video. You'll see our video running, and
Okay.
these technologies are already matured enough. And we also we are a running engine, so
Yeah,
we have
yeah.
our team is mashallah has done enough good job on this. They can control this.
Okay, so
they have control this.
Okay, so you were not using any kind of actuators in this process?
No,
correct?
no.
Okay, okay. Please continue.
It is a thermal cycle. It is a thermal cycle.
Okay.
I also request the participants that if we can ask the questions towards the end of the presentation, so that all the questions get answered one by one as well.
Sorry for my interruption. I thought maybe you were asking, so I didn't know.
No, you can leave the question in the chat box, and
Okay.
then Dr. Arshad will be the panelist for the question and answer session. So
Okay.
we'll try to answer all the questions.
Okay, thanks. Yep.
So this is one of the pictures of running, and this is one of the pictures conducted, taken during a test conducted, and it is running engine. You can maybe see the RPMs and the temperature in the digital display of this picture. And this is just the startup. It's not full power. Okay, may I move now next? Now coming to technical specifications. We have developed 120 Newton and 180 Newton, and according to our studies, we are planning to go to 800 Newton for in recent future, near future, and where we can have electrical output from 3 to 500 kilowatt electrical, and thermal output for 3 to 1500 kilowatt thermal, and exhaust gas temperature between up to 850 degrees centigrade. We have fuel flexibility of using natural gas, sour gas, gasoline, kerosene, diesel fuel, biofuels, etc. And we have targeting electrical efficiency from 23 to 40%, and whereas total efficiency in CSP mode from 80 to 90%. Okay. Reliability in life. These turbines have been designed to work with 42,000 to 80,000 hours with overhaul. And emission targeting below 3 ppm for NOx on fossil fuels comparatively. This will be our range. And the noise level we are maintaining 50 dBA. These turbines are modular, and the infrastructure is also very modular, easily workable for maintenance. Compact system, which is 0.045 to 0.065 cubic meter kilowatt per kilowatt E. These turbines are low maintenance. Typical single radial stage and single rotating part no moving parts. And now you'll see in a later part of the technologies where type of bearings are used, there is no lubrication also. Again, reliability, because there's very less number of parts involved into this gas turbine, so it is very reliable and robust. Compactness is because of the high energy density, use of high-speed generators, and turbine itself is a very small system, very compact to develop modular power up to the range of 50 kilowatt. So you can stack up various modules to develop powers in the multiples of 50 kilowatt. These have fuel flexibility, and diverse fuels can be used from jet fuel, diesel, and biofuel, as I said. This is the most interesting part in European Union at the moment, is try to use biofuels. But at the same time, their consumption, because of the NOx emissions are very low. So even on diesel also, they are considered very low. The other application, maybe for the audience, it is CSP. Is a concentrated solar power application. In this application, the dish is used to direct the sun energy on combustion chamber to give heat to the turbine. These are low emission turbines, low NOx as compared to reciprocating engines. So that is one of the reasons why European Union and world is moving towards micro gas turbine, even in renewable energy solutions. They are low noise. The combustion noise is very low as compared to reciprocating engines. This is a very high frequency noise, and which can be attenuated relatively easily. And they have got low vibrations compared to reciprocating engines. And CSP mode can be used for high heat and low electrical power. It depends, because in this mode, you can choose between the two. You want heat load more, or you want electrical load. You can adjust accordingly, and we can meet the requirement of the end user. And there's another, it is integration with fuel cell. And integration with fuel cell, this, the byproduct, the heat is used to heat the solid fuel of used in the fuel cell. The applications are combined heat and power, and combined heat and cooling and heat power for domestic and industrial uses, and the automotive range extenders. Now, because in hybrid vehicles, the batteries were not considered enough for a long endurance. So these in hybrid vehicles, the micro gas turbines are being used to enhance the range of the hybrid vehicles. And in future, these are going to be used in Europe, in future train and rail transport. And in oil and gas sector, preventing a flare basically is a normally they are continuously they are venting their gas into atmosphere. So European Union has banned this use of this venting this flare into atmosphere. So micro gas turbines are being used to produce heat and electricity using that gas also. So this has another application. Concentrated solar power, as I said, using the solar power concentrated heat on a combustion chamber to use with the in combination of solar energy and gas turbine. And moreover, one of the popular uses is small UAVs and APUs in another area where these micro gas turbine can be used. And again, due to their minimum size, these are being adopted as a backup power energy instead of using batteries with renewable energy plants. So please.
So you've spoken about the micro gas turbines. So what other products your company is actually working that have the export level potential?
My next few slides would indicate you some pictorial views so that you can have an idea what we are actually developing beside this range. High-speed target drone launching system. This is the system which has been developed in Pakistan and designed and developed in Pakistan. And the picture you are seeing at the moment is the transport mode. It is in the folded state where it can be transported. In the next, you will see the deployed state. The system is in deployed state. The system has got the capability to launch masses up to 150 kg and with speed of 55 meter per second. The weight of the launcher is 5,500 kg, easily deployable with 16 meter length, and it has transportable length is 6 meter, can be easily transported in a 20 feet container. This is being operated with high pressure air, 150 bar, can be deployed at sea and land. And this system can launch systems, deploy UAVs with the force up to 15 Gs controllable using our system. This is some of the pictures of 200 kg UAV being launched. It is a dummy. It's this is at the moment this dummy is without any propulsion system. It is just metal dummy. This is some of the picture of again a dummy being launched without a with the power, just to show how much energy this system has got. We are now in high-speed target drone systems for training of pilot and for various commercial uses. It's a high-powered systems, can go up to 0.4 Mach. And this system has been designed for being used for our launcher. And this is one of the UAV for smaller low-speed system for IR tracking system. This is unconventional wings. This has been developed by us. This is for small, we're getting small payload capacities for aerial videos or pictures on a disaster area. This is a small unmanned underwater vehicle used for survey of the seabed during disaster to submarine or a ship or a survey of oil rigs. This is fitted with a camera in the nose to carry out survey and can be controlled with wire or wireless, and the depths can be adjusted. This is another unmanned ground vehicles. This is a robot manufactured at our facility. This is autonomous. It also has camera for surveying and other activities. It can manually handle pick up things during disaster survey of a damaged area during fire or flooding. This autonomous robot can give you feedback to the end user to the system. High strength materials. These are the lightweight, high strength materials being developed. Research was done, and alhamdulillah we have developed. And now you can see mark to protect the high energy bullets. We have developed locally. You can see how bullet has been prevented. This is the front end. We are into some precision manufacturing. We develop connectors. You can imagine the accuracy is required for these type of connectors. There are things. Okay.
All right.
Maybe just.
Sir, what
sure.
is? Yeah.
Sure. Okay, please.
I would like to ask basically that what is the potential market you see for all your products, and what are the export capabilities?
Frankly, we are at the moment targeting Central and Eastern Europe, Canada, South Asian, ASEAN, Gulf, Central Asian countries. And some of the African countries has shown interest into us, and the Pakistan, of course. These countries have shown interest, and for this actually we have participated in few exhibitions also. So we have seen quite a good encouraging response from these countries. Yes. And the export capabilities we have, like all our products, because micro gas turbine, high-speed launching systems, automatic disarming system. This is I've not displayed here. we maybe show you a video for this system. This system can disarm ammunition which is expired, can be dismantled automatically. Our high strength material have been results were very encouraging with some of the companies have shown interest for bulletproof jackets and materials, and high performance actuators for pneumatic systems. And automobile industry, we have some of the offshoot technologies coming out of these products applicable in automotive industry.
All right.
Okay.
So, Sajid, what is the future outlook of the Solidnox, and what is your advice for venturing into new technologies in Pakistan?
Frankly, in the future outlook, we see raising the capacity of these micro gas turbine, and in the CSP mode, because this is going to be the future of the world. Maybe in Pakistan it may take some time to come to this level, but Europe and Americas, they are focusing it. Even Japan is focusing on these technologies. So we are targeting these countries for, and that is why we have developed our trajectory towards these technologies. And then we have high-speed launching systems and from European and US market, and unmanned systems from ground, air, and underwater systems. And we have UAVs for agriculture used with IoT, and we have targeting hybrid power for high-performance marine platforms, innovative transportation system, inside building positioning system, and protection against EMC, EMI, fire and water. These are few areas because the offshoot technologies of our research done so far. Okay.
All right. So, Sajid, moving towards the end of my question from you regarding the presentation, is that how the government of Pakistan can help Solidnox, and what examples they exist in other countries for supporting such technologies?
Okay. In fact, Solidnox research is ready to lead Pakistan towards cutting-edge technologies in power and energy domain. Entire effort is exactly aligned with government vision. So we expect once we are already aligned, and maybe we are talking about for Pakistani administration, develop this understanding of low emission or low NOx and other areas. They may like to come up maybe at the later stages, but at the moment we at SoluNox have developed future technologies in this time period. So what we are expecting from government or public sector organization, if they think they want to avail our expertise in these technologies, we are ready to give our expertise gained so far, and technologies can be ecosystem. We can help the government organizations to develop this ecosystem in Pakistan. And important thing is with this ecosystem should be beneficial for both parties. Like we are a private entity. We have used all our resources. As I mentioned you in the start of the process, that even European Union has invested 1.6 million euros only for the study to develop gas turbine, whereas SoluNox is using its own resources to carry out this research, and today we have reached to this level. So we would like that we will be ready to do business, of course, for a profitable business, of course. I will not shy in saying that, because we have done so much up till now. So we are ready to even extend our services to academia for training, for education to university students and tradesmen. And frankly, there is a huge demand of made in Pakistan cutting edge technologies in Pakistan. You see, all stakeholders now have to play their parts to establish this ecosystem. Alone, maybe I may sustain in Pakistan for quite some time with our own resources, but you can see the level of technology we are talking about is has developed interest for so much of audience in Pakistan at the moment and internationally. So we would expect this now. All stakeholders have to come in now to take this. I don't know how, but since to make this our business sustainable, we would expect government to come in at a government level. They come up with some ideas, or maybe we are ready to give our ideas to the government. So most important thing out of all these things is the ecosystem. When I say ecosystem, what I mean is because research cannot take place without a formal education, for sure. It is not possible that anybody come in and start working on gas turbine or similar technologies. So you must have a good formal education. The good part in Pakistan is that we have abundance of innovative formal education. We have got so much PhDs in related technologies working in Pakistan and outside Pakistan, and ready to serve in Pakistan also. The only issue which at the moment Pakistan has suffered now, and Alhamdulillah, what Solidnox has make a difference is that we have access to innovative hand-on experience. Those who are actually can work on gas turbine, those who know the philosophy of manufacturing of making a gas turbine and the precision requirement of a precision in this type of technologies. Then comes the tested knowledge. This is another area of knowledge which normally the West is very much relying on, because in Pakistan, if you manage to get hands-on experience, but we lack is tacit knowledge. We don't have any system mechanism in Pakistan at the moment to harness tested knowledge. So if you have formal education alone, will not solve your purpose. Even if you have hands-on experience, you will manage some, but you will not able to explore complete area. But the tacit knowledge is the area which depletes with age and time. Unless this is not harnessed, this complete process will not find. Even I have heard Lockheed Martin CEO reaching US president that if America does not focus on STEM education, the Lockheed Martin will not be able to maintain its edge in aerospace and defense. So you can imagine it's not only engineering knowledge, but the STEM knowledge is so important for this type of technology to prevail in any geographical boundary. So the other part which we are doing is we are taking design project management. This term we are following because generally project management is a complete discipline. But we have taken design project management as a complete skill and a discipline. And we are applying our generalized project management tools into design process. And this is where we are ready to give our input to the university level, how this design project management is achievable using while doing within our universities and area industry. So this was I said, maybe if you like that, I can show you some small videos. It will be small some of the products live.
Please.
Absolutely.
Let me share it with you. Okay.
So meanwhile, you're opening the presentation, I would like to thank you for such a thought-provoking presentation and for giving us an insight that individuals like you are working on their own levels, individual capacities in the high-tech sector in Pakistan. So it was a new insight, and thank you for such a great presentation.
Okay, thank you. This is one product which we did not discuss in the presentation. This is an automatic system totally designed and manufactured by our young, talented engineers. This system is dismantling expired ammunition automatically with just click of a button. Okay.
Next video.
So is this the same device that you were showing us? Is
Sorry?
this the same instrument?
Same.
Yeah.
Maybe
You can go to the next video.
now you'll see gas turbine trial. Hmm? Thank you.
Okay.
Thank you so much, sir. So I would
Thank
now request our panelist, Dr. Arshad Ali, to please take over from now and say over to you.
you very much. First of all, thank you very much, Tareen Saab. Generally, what happens is that a person after retirement just try to make a dua and remain close to the masjid and prepare for the last run. While you must be doing that as well, but you have taken the initiative to have a startup and invest your own resources. We are extremely proud of this particular effort. I'm sure while being Muslim, we pray and prepare for our end. At the same time, such a service for the nation and the society is extremely important. Now I will invite President of Pakistan Aerospace Council, Dr. Harun Qureshi. He has comments as well as questions. So over to Dr. Harun, please.
Yes, thank you very much, Dr. Arshad, and thank you very much, Sajid Tareen Saab. Your presentation was most encouraging, very encouraging. Your energy in doing something in advanced technologies for Pakistan is most appreciable and commendable. In fact, as Dr. Arshad said, most people retired from the armed forces. You are one of those who stand out. The knowledge and the experience that you have applied it to developing something on your own for Pakistan. I just have a couple of questions. आपने अपने आप को इतना ज़्यादा R&D में spread किया है, from micro turbines to launchers for small UAVs or medium-sized UAVs and to other technologies. अभी तक I'm certain कि जो कुछ भी आप काम कर रहे हैं वो आपका self-funded है या किसी ने इसको fund किया है. My first question, how do you see it becoming self-sustainable? Have you made any money yet? Have you had any sales yet, which can actually sustain you? Second, sustenance at times has to be possibly done on a month-to-month basis. If you have one sale in 3 years and you have to pay salaries every month, then your R&D and your energy may not be able to kind of live up to the expectations of your lady wife. आप किचन ना चला तो वो आपकी सारी R&D और सब कुछ बंद करवा देगी because you have no money coming in. So I'm sure you have worked out a plan कि sustainable कैसे होगा. How will any of these products have a sustainable cash flow? Number two, a comment and a advice. If you're expecting that government of Pakistan, or for that matter, any of the government, can actually support your venture, then in my long experience, this is a losing proposition. If it is self-sustainable, आप खुद उसको sustain कर सकते हैं without expecting any government to support you, तब तो ये बहुत viable है, and inshallah your R&D and a lot of your work is going to go a long way. But if you're expecting that some government is going to come and support you, so उसमें फिर I'll be very surprised if that really happens. And at times हमारी अपनी जो government की R&D facilities हैं या establishments हैं, वो आपसे technology of transfer technology मांगेंगे. Effectively they will try and duplicate your work and say कि अगर आप कर सकते हैं तो कोई सरकारी इदारा क्यों नहीं कर सकता. That's my 35 years of experience. That if you can do it, why can't another state establishment do it, and so on and so forth. So let me not sound negative. I am so very proud of you and your spirit and your energy, and most of all, you being a Pakistani. And you're no less than nobody else in the world in terms of what you're doing and your aspiration and your energy. And before I give it back to you, thank you very much, AIA and PAEC
just
for
organizing. Sir, basically,
sir?
So just to interrupt you because there is a power failure here. I lost contact.
अच्छा चले we'll continue उसके बाद करेंगे. मैं सिर्फ I want to commend AIA and PAEC for holding this webinar, and must appreciate Bakhtawar for moderating it so well. So thank you very much. From my side, back to Dr. Rashid Ali.
Ji, Sajid Saab, your comments.
Sir, my request is at the moment there is power failure. I lost the contact. I would request Bakhtawar to can you repeat if there are questions by Sir Harun. If you could repeat these questions by
जी मैं अर्ज कर रहा था कि आपकी स्पिरिट और आपकी जो एनर्जी है इट्स मोस्ट कमेंडेबल. अभी तक आपने जो कुछ भी किया है गालिबन ये आपकी अपनी रिसोर्सेज से हुआ है. Do you see a sustainable business model for any of these products in the short run and in the long run? Short run ये है कि अगले 6 महीने में अपने आप को कैसे अफोर्ड करेंगे. In the long run क्या इसमें sustainability है कि कुछ ऐसी products हैं जो कि अपने आप को बेचेंगी और आपका जो पूरा cash flow है उसको manage करेंगे. So a lot of appreciation for you and a lot of good wishes from both from PAEC. PAEC stands proud to have you as part of, as our Vice President from the South region, and also to have you as a part of the Pakistan high-tech aerospace industry. Please go ahead, sir.
Thank you very much.
Sajid Saab, just one comment. We have quite a good number of questions, so kindly be specific and fair.
I like Sir Harun's question regarding how it's going to be sustainable. There is no doubt about the potential of these products because it's a very high valued products. But it's just a matter of time because after my playing first inning, I was coming as a startup. For me, it's very important to have some product in my hand. I didn't want to be a trader, frankly. So what I decided, I have to have my own hands, must have something in my hand, that is these R&D. So R&D is now I have my own 5 patented products, which now I'm going to sell.
I think there is an internet issue at the moment. Dr. Arshad, if you would like to take any comments from any of the panelists over here, let me contact Sajid Saab if the connection works fine for him.
Yes, if you can take him on telephone, and then he can then maybe convey on telephone.
Join us. Oh, he's back. He's back.
Okay. Sajid Saab, are you back? Sajid Saab.
So please unmute your mic.
Mic off है. Sajid, आपका mic off है.
Hello.
Sajid, mic off है आप. You are back. Thank you.
Yes, sir. So this was actually basic requirement for me to have some product in my hand. So thus, in last 4 years, I have done a lot of effort to get these products, my own product. Now I am the OEM of these products. So this is the added advantage I have. For sure, in next 6 months or maybe 1 year, this is going to be my marketing year. Like this webinar is one attempt to have this marketing now, because we have developed these technologies, and now we are fairly confident to have this, to make an impact even in international markets. Like I said, we have participated in ideas, we have participated in IDEX Abu Dhabi twice, and just to we have few companies, government companies, international government companies are with us to collaborate with us. We are working with some ASEAN countries, companies that are working with us to take advantage from our know-how. So we are already into this market, and we have, the good part is that we have good 5 or 6 Pakistani products in our hands, and we are the proud OEMs of these products.
Thank you very much. We have with us Farhan Hafiz. I remember he used to work for Pratt & Whitney in Canada. I don't know still he's with them or not. So Farhan, over to you, please.
Thank you, Arshad. As you have rightly pointed out, yes, I still work with Pratt & Whitney Canada. My experience is development systems for turbofan engines, and now I'm doing project management. So with that behind me, I would like to have a few questions. The questions are a bit leading questions. They are small, but I would like to get to some information, because I'm a little confused, because the title of the presentation was micro turbines, but we talked about so many things. So starting with the thing you mentioned, that these are eco-friendly engines. So how are they eco-friendly? I mean, you talked about power generation. How do you extract power from these engines? Yes. That's question number 1. And then I'll follow with more.
Okay.
Can you please go ahead with your question so that they are answered with...
replying for the first question.
Farhan, can you have...
Hello.
Okay, Sajid Saab, you can...
audible?
You are audible. Can you respond to the first question? Sajid Saab, you are audible. Can you respond to the first question, please?
Yes, I can respond to the question. Okay. You know, in as I told you, some more countries, they have conducted a study in last 6 years, in say 2014 and 2016. There was a project by European Union for 1.6 million euros to make power turbines from these gas turbines, right? So we started this research study and all that. We, in a very limited period of time, we were able to manage gas turbine is in the propulsion mode. But just for the information of the audience, that we are Alhamdulillah, joining with some UK-based company, those who are going to work with us to convert these turbines into power turbines by next June, hopefully. And we, for this process, we are actually, again, one of the very purpose of this webinar was that we are coming to the government now, that we need funding for these projects now. So we have managed to develop gas turbine parts. Now, in the next 8-9 months, we are going to work on the design to convert these same products into power turbines, electrical power turbines. So one agreement we have done with the UK-based university and the company, those who are ready to work with us, and to develop and market this product in Asian countries, even in UK and in European Union. So this is one part of your answer which you've asked. So we are going to make it like this. So at the moment, what you are seeing is the turbines in propulsion mode.
Okay, thank you. The other question is that these micro turbines were originally, from what I gather.
Hope that answers.
Yes, it does. Thank you. So the second question I have is that you mentioned that these are.
I cannot hear you.
Can you hear me?
Can you please repeat?
Yes, I said during the presentation you mentioned that these are eco-friendly engines. Based on my past experience of 18 years working in the engine development design, as the engines become smaller and smaller, their efficiencies become less and less. Larger the engine is, the more efficient it is. Micro turbines, as you had rightly pointed out during the presentation, run at around 100,000 plus RPM. At those speeds, the efficiencies go out of the window. So how are you claiming that these are efficient engines? Because running at high speed, high temperatures, the efficiencies are extremely impossible to manage.
You're right. Okay. Yes, you're right. In this mode, you'll find efficiencies in the range of 50 to 60%. However, but some innovative methods we are targeting this micro gas turbines for special purpose for renewable energy integration with renewable energy. So for that, the target is for electrical power around 24 or 30% efficiency using recuperators. And to make it efficient for CSP mode for thermal, this can go up to 70 to 80%. Of course, it's an evolution process. Okay, so to make them turbine efficient for CSP mode, can be so that it can be used with renewable energy grids, with fuel cell or wind turbines, and these turbines will be used as a backup turbines to sustain that irregular supply of electricity. So these turbines have proven good in the recent studies has shown, and alhamdulillah, we are following this pattern.
Thank you very much.
Even if we have managed to get 25-30% this with recuperators, so this is because, as you said, they have gas turbines in this range are 15% efficient, but making it 25-30% is going to be target.
Thank you very much. Actually, efficiency has a lot to do with the kind of applications we are dealing with. And generally, people sitting in the West start comparing the work with the latest technologies and the companies. But in the developing part of the world, whatsoever innovation, supplementary innovation we do, I think that is a big step with kind of limitations we have in our ecosystem. So that is very, very important to keep in mind. So we have Dr. Sara Qureshi with us. She's doing excellent work. Sara, would you like to have some comments or question, please?
Okay. Assalamu alaikum.
Walaikum salam.
Ji, Assalamu alaikum. Can you hear me well?
Sure, we can hear you very well.
Okay. I'm not turning on the video because it just because we don't have a very strong connection. Um, I have a lot of questions, and it's great work that you are doing. Congratulations. And my first question is about you're doing some parts in house. So I would like to know about your experience with Inconel, and whether you have any experience with its casting or machining. And then my second question is about your access to bearings, as you mentioned that you are going up to 120,000 RPM. So, where are you getting those bearings for high speeds? And the third question is that, is this R&D, just R&D, or are you also in production, or the number of, have you developed a single prototype, or you have some number of prototypes available, and also the percentage of components that you are manufacturing or developing in-house, and maybe sub modules that you are doing in-house. I mean, these, and I would obviously prefer that we have a live presentation as well. It's a bit disturbed on Zoom, but anyways, if you could answer my questions.
Dr. Sarah, thank you very much. Dr. Sarah, thank you very much for your question. But unfortunately, now communication is actually getting problematic now. Question I could get that from the word you said, Inconel. From Inconel, you were interested, what is our experience on Inconel?
Yes.
And regarding bearing technologies and to start with, Inconel is a very good experience with Inconel. We are doing on Inconel. And rest other technologies, we have using hybrid bearings.
Please go ahead.
We are going with hybrid bearings. And then we have other options with air bearings and magnetic bearings. So somehow we are able to manage this. And regarding your question about how many projects or prototypes we develop, at the moment we have developed 4 versions of the engine. 2 did not work well. However, the remaining, I said 120 Newton and 180 Newton, they are functioning well. And we are testing on the ground. And hopefully by end of this year, we are targeting to make it flyworthy.
Okay, thank you very much. Can we have a question and comment? Ikram, please.
My co-founder, the CTO of the company, Mr. Masood Qureshi, is also here with me. He would like to ask a question, if it's okay.
Sure. Masood Saab is very senior person retired from Atomic Energy Commission, and once I had the opportunity to visit, I was extremely impressed to see the work he is doing. Ji, Masood Saab.
Assalamu alaikum. Okay, I just had, I won't take too much time. I just had a few questions. Now, the word microturbine, I probably missed out because I just joined the conversation. So, at what stage would you call a turbine a microturbine? Now, that is important. Yes. Secondly, is if you're what is the size? And I assume if you are running it at 120,000 RPM, the diameter with the tip velocity would have to remain subsonic. So from combining these two questions, I would like to know where you call at a micro turbine.
Thank you, sir, for your question. Sir, micro gas turbine historically started to call 1 kilowatt to 1 megawatt. But this idea did not last long. And until recently, the last study conducted by European Union, they have taken micro gas turbines having power 400 kilowatt and 1 kilowatt would be graded as a micro gas turbine. Sir? Right, sir?
What would be the diameter of the impeller or its largest rotating element?
180. Turbine diameter. Yes, sir. Can you hold some? Let me confirm. 17 turbine. 70 mm is turbine. 180 Newton. Sir, can you hear me?
Ji Tareen sir.
Sir, I have finished my answer. Is it audible now?
So your voice is not clear. Can you please repeat the question again?
Okay, I can. The question was regarding that what is the power requirement for a micro gas turbine to be called a micro gas turbine to be called a micro gas turbine. And the other question was, what is the diameters of our gas turbine engine? So I said we are using two types of, at the moment, the product we have made is 120 Newton and 180 Newton. For 180 Newton, the diameter is 70 mm. And the weight of complete engine is 1.5 kg.
The kind of resilience Sajid Tareen has making a presentation in these times from Karachi is itself a very big task because everywhere there are electrical outages and so many problems. So we are extremely proud of you and appreciate your efforts. Over to Bakhtawar for the closing remarks.
So first of all, thank you to all the panelists and the audience available. Thank you for taking out time, and thank you, Sadisa, for an excellent presentation. That it was thought-provoking and it was actually a very inspirational one. So signing off with this, and I would request all the participants who are available at this point to please like the official platforms of all the social media platforms available for the Pakistan Aerospace Council and AIIA. All the recording link will be shared in the chat comment as well. And thank you all for your presence.